Why do the most advanced AI models on the planet confidently lie to us? Seriously, they'll just invent facts, make up sources, and spin this plausible sounding nonsense. And it's a problem that's been ridiculously hard to solve. We've got this fancy name for it, hallucinations. But is it some deep, mysterious glitch in the system? Or is something else entirely going on? All right, let's get into it. So to kick things off, a little pop quiz for you. Adam Kalai is a top researcher at OpenAI. All I want to know is the title of his PhD dissertation. Seems like a super simple, factual question an AI should be able to nail, right? Well, when researchers asked this exact question, they got three completely different answers from three of the biggest models out there. You've got ChatGPT, DeepSeek, and Llama, all proposing totally different titles, different years, even different universities. I mean, they sound super specific and believable, but every single one of them is dead wrong. Yeah, the real title is Probabilistic and Online Methods in Machine Learning from back in 2001. Not even remotely close. And this is a perfect textbook example of what we're talking about. This whole phenomenon has a name, hallucination. And no, it's not about the AI literally seeing things. It's when the model spits out a statement that sounds perfectly reasonable, totally confident, but is just factually incorrect. And as we just saw, it happens all the time. But the real question is, why? To really get to the bottom of this, we have to go way back to the beginning, to how these models learned to speak our language in the first place. At their very core, large language models are basically just incredibly powerful pattern matchers. Their first job, what we call pre-training, is a simple game: predict the next word. They just churn through colossal amounts of text from the internet, learning the rhythm and rules of human language. Now, this method is fantastic for learning things that have consistent patterns. Spelling, grammar, those things show up millions of times, so the AI gets really good at them. But it's not so great with these random one-off facts. Things like a specific person's birthday or, a dissertation title. There's no predictable pattern there, so the model can't really learn it in the same way. Okay, so that explains why the models might not know something. But it doesn't explain why they're so confidently wrong, instead of just saying, hey, I don't know. And that brings us to what the researchers call the test taker's dilemma. This quote from the research paper just nails it. The models behave exactly like students cramming for a huge exam. When they hit a question they're not sure about, they've learned that it's often better to just take a guess. And here is the trap we've set. In most of the tests we use to grade these AIs, taking a guess gives you at least a small chance of getting it right and scoring a point. But saying, I don't know, that's a guaranteed 0 every single time. So what happens? The model that learns to bluff gets a higher score. We are literally training them to lie. And you can see this in the actual data. It's wild. So here we have two models. Let's call one the guesser. It almost never admits it doesn't know. The other one, the humble model, says, I don't know more than half the time. Now look at the accuracy. The guesser is slightly more accurate, 24% versus 22%. But just look at that error rate. This is the hidden cost right here. The guesser model is wrong a staggering 75% of the time. That is nearly 3 times more hallucinations than the humble model. And yet, on a lot of leaderboards that only really care about that top-line accuracy score, the guesser actually looks a tiny bit better. We're rewarding the wrong behavior. So, if the problem is how we grade them, what's the solution? Well, the good news is the researchers have a really straightforward fix that could put these models on a path to being more honest. The fix is brilliantly simple. Just change the scoring system. First, if an AI is confidently wrong, you penalize it more heavily. And second, you actually give it some credit for saying I don't know when that's the right move. It's exactly how some standardized tests work, right? They penalize you for random guessing to get a true score of what you actually know. But here's the key part. This isn't about creating a bunch of new little side tests just for hallucinations. The researchers argue that we need to fix the scoring on the big mainstream leaderboards, the ones that everyone in the AI world pays attention to. Because if those main scoreboards keep rewarding lucky guesses, the models are just going to keep on guessing. And once you see it this way, it completely changes how you think about this problem and what it means for building AI we can actually trust. So let's just bust some of these common myths, okay? Myth 1, hallucinations are some inevitable, mysterious glitch. Nope, they are a predictable result of how we test them. Myth 2, they'll just go away as models get bigger and smarter. Nope, again. There will always be questions the AI can't answer, and as long as we reward guessing, they'll guess. And myth 3,
only the biggest, most powerful models can be honest. Absolutely not. The research shows a smaller model can actually be better at knowing what it doesn't know.
So here is the single most important takeaway. Hallucinations are not a bug. They are a learned behavior. We've accidentally created a school where the students who bluff their way through the test get better grades. The AI isn't broken, it's just being a very good student in a system with the wrong incentives. And that leaves us with a really fascinating question to think about. As we keep building these incredible systems, what do we actually value more? Do we want an AI that tries to be helpful 100% of the time, even if it has to make stuff up? Or do we want an AI that's only confident when it's right and is honest enough to tell us when it's not? The path to a truly trustworthy AI really depends on which one of those we decide to reward.